Everyone, today we are going to see that how a TCP is going to work in the Wireshark and what is the TCP protocol according to the computer networks. So we'll go into our first topic as per TCP in the Wireshark Lab. So today we see that first of all we want to know that what is meant by TCP and what is the significance and what are the features of the TCP. TCP, also known also is a full form of the TCP is Transmission Control Protocol. It is a reliable transport protocol. It is used to establish the connection between any two devices or any number of devices. And if the data is any error is present, then it is going to ensure that the data error can be rescued. So you want to know what is the significance of the TCP now. TCP plays a significant role in the backbone of the internet. So we see that the internet protocol IP address, and it is mostly used protocol for sending the data and data packets. If you want to send the data from client to the server, then it is used as the most important one. So now we want to know the what are the features of the TCP. TCP contains the mainly features like it is used for the error detection of the data and the correction of the data. It also controls the flow control. And if we have any error in the data, it is used to control the errors by flow control and congestion control and mechanism to prevent the net control. So we will see now how this TCP going to work. So here you can see the TCP lab, how it is going to work. In this TCP we are going to see that. First we are going to see this lab capturing a bulk TCP transfer from a computer to a remote server. So how this TCP is going to work, we can see in this lab and different stages of the TCP, how we are going to capture the packets of the TCP according to the HTTP post. So here you can see, uh, first of all, do the following. So what they have told us is that start up your web browser, go to the this link. So what is this link present means? We will see this one. You can have open in the new tab. So here is a text. This is called LS text. Means LS text contains different type of chapters like how these Wireshark or how this TCP or other type of protocol how they are going to work. They are written in a book by the chapter wise. So we are going first of all download this LS text. So I have already downloaded the LS text. Here you can see the LS text. Here is the LS text. Then we are going to see that. Then next go to this website. So open this website. So which you have finally downloaded the LS folder. Just browse and paste here. So I'm going to paste here. Before going to upload this LS text, then first go to the Wireshark Lab. So we want to know how a Wireshark is going to work. We will see now. Go to the Wireshark and let the package capture by the Wireshark. So what traffic you are using, please select the traffic like Wi-Fi or Ethernet or anything. Here I am using the Ethernet, so it is showing the traffic system Ethernet. Please do capture the packets. Here I have captured the packet. Then from here to our file aspects, then upload here. So these aspects will be combined to the just Wireshark and the packets will be combined here. Here you can see we have transferred a copy of LS from your computer to this link. We should now start the Wireshark packets and start analyzing the packets. So I'm going to stop here. So now this Wireshark will retrieve to the document which we have uploaded now. See next what is the step shown here. So we have done all these three steps. Now see going to the filter packets do TCP. So I am going to Wireshark now and display filter packets I am using the TCP. So here you can see what are the different type of protocol which are related to the TCP. All the protocols are captured here. Here you can see the TCP here. So now see what happens next. We look at now we are going to second step. We look at the captured trace. So what is the packet is? In this packet which are captured by the TCP, in that package there is a this is called a HTTP post. So all the other information which we are going to see, all this information is held or posted in the HTTP post. It is it can be observed here. If you selected any packet here, here you can see in the ASCII code side, you will get the post. For example, if we select any packet here, push anything here. So we did not find any post here. So select anything, uh, observe the code that is post. Type menu post. Mm, so we will next observe that one. So next we are going to see that the HTTP configuration messages in this Wireshark Lab. So all we have done here, if you are not unable to submit or upload the ls text, then you have to download the zip file, then unzip the file, extract all the files. You will see a packet called the TCP eternal trace one. So please upload this eternal trace one in the file. Come to here, file comma, and here you will see that the import and export. So in this you can also import the file which is present in the ls eternal, which is shown here, that is eternal trace one. So now we are going to answer these questions. So see what the question is asked. What is the IP address and the TCP port number used by the client computer? What is the transmission file? To answer this question, this probably they also given the hint, that is at Wireshark Lab in Lab 1. So what they ask, what is the IP address and TCP port number used by the computer client computer. So come here, protocol or length. Here you can see in this you will see, here you can see destination port number and source port number. So the source port number is 7680 and destination port number is 62790. Sequence number is 6363 and 43. All the information of the TCP is transmission control protocol. All these are present in this folder. Here you can see the ASCII code. So that is only I have written here. Here you can see. Here you can see that the first question I have answered. So the port number, in this figure you can see that the port number, sequence number, destination number, all the stream data, stream index. So now we are going to see the second question that is given. What is the IP address of the GIA.cs individual? On what port number it is sending and receiving the TCP segments? So here you can see in the Wireshark Lab, the thing which we have retrieved, like we have uploaded a file, that file now. So that file is going to retrieve here. So here what they ask me, what is the destination port number? My destination port number is 62790 according to the data transmitted by the ls text. If you want to see that, just press the link, then you will get directly access to the package captured by the Wireshark. So now we are going to see the third question. What is the IP address and TCP port number used by the client computer? So now we are going to see that one. So every time we are using the same port number, because of using the same computer will have the same destination address and the source address. So port number also will be become the same for the all the time. Here you can see my sequence number, and this is the source port number and destination port number. So source port number will not change because destination port number will be changed sometimes. So we have completed this first one. So now we will see same TCP segmentation now we have got here. Same we are going to see the TCP basics. In TCP basics, what they have said, what is the sequence number of the TCP SYN segment? What they have said, TCP SYN segment. So please check the TCP SYN means sequence. So I am going to click here TCP segment assembly. So TCP SYN. Please check the sequence number where you are getting a SYN acknowledgement number, and these all are acknowledgement number. ACK means acknowledgement. Let me please SYN number. We are going to check. Where is the SYN number? Let me check for the SYN number. Here you can see SYN sequence number, this is SYN sequence number. So what they are asked here, TCP SYN segment. What is the sequence number they have asked? So go to this one. I have selected the packet. They have asked for the sequence number. Here you can see the sequence number is 0, but sequence number here are 238442025. So I have got the sequence number. The question what they have asked me. Now they are asking the sequence number, the segment of SYN acknowledgment number with it. So we have selected only SYN segment. Now we have to select SYN segment along with the acknowledgment number. So check for the SYN plus acknowledgment number. So going to check for the SYN and acknowledgment number. Let me check for the packets. Acknowledgement. Go to length. So this will capture SYN. And here we can get the A sequence number. What now I ask for the sequence number. So when I have selected this one, they have directly shown the sequence number here. So the sequence number is 4179516. So here you have also see that the acknowledgement number also, ACK number. So I have got the first one also. So same that only I have shown here also. Answer the questions. So same here you can see the segment is equal to set and the sequence number is equal to something same. And fifth one, 237, and at the time of which I am going select first I have used the Wireshark for this one, then I have got the sys number. So next we are going to see the next question. What is sequence number of TCP segment containing HTTP post? Now they ask you for the. Now we have going to first one I have said that we have going to see here in the ASCII code we will get the post. So now we have to select the segment which contain post segment. So let me check for the post. Here you can see if I select this push from ACK sequence is equal to 1, then I have got the ASCII code that is POC post Wireshark Lab. Means it is retrieve the data which I have uploaded in the LS text. So I have got TCP segment 714 bytes. That is one. Same which now I have asked now, 7th question. What is sequence number TCP segment containing HTTP post? I have got a sequence number G6675. Here you can see the same number which I have got. Sequence number G6672. So consider TCP segment question. Consider the TCP segment containing HTTP post as the first segment. So I will go for this one. You have to go to the website. If you selected something here, so what they ask means, please show me that the time sequence from the starting to ending. So go to time. Here you can see this is the entry point. From entry point we have got something to exit point. So something is going to in and something is going to out. So if you select different type of the protocols, different type of the protocols have a different type of the timing. So from which time they have entered into the port and from which time they are out of the port. So all these are given here. So going to enter the source, then you can click the time. Here you can see 0.125457 time. The next port is 0.125571. If you want to get the time, we have to subtract from higher value to the lower value, means 1255112 125457. If we subtracted these two, then we will get the time which they are going to, from which time entered and the time when they are going out. So not only that, we can also get here the time value, means you can check the timestamps. Here you can see time since the first frame in this is in time and this is out time since previous this is this machine. So how we got these two time? We are going to subtract the higher value minus lower value. Same I have done here. You can say time duration equals 6.18. Requirement is 6.18. Here RTT, they have asked for the estimated RTT. So what is the RTT means round trip time. So what I did is simply subtracted higher value with the lower value. So I have got this one. So what is going to the eighth question? What they ask in the eighth question is what is the length of the first six TCP segments? Here you can see eighth question. So in this eighth question, what they ask is note. I have given a note. Wireshark has done a nice feature that allows you to plot the RTT file each TCP segment sent. Select a TCP segment in the listing of captured packets window that is being sent from the client to the server, then select statics. So this is simply we can make that selecting a TCP packet. Then we are going to that edit. In the edit, sorry, not in the static, we are going to select that the TCP stream log. In TCP stream log, we can also select the round trip and we have different type of the streams here. So if you want to select for the TCP segment, you can select the TCP trace. Hey, what they ask is round trip time. So now we can go to the round trip time. So you go to round trip time and select the RTT by sequence number, and you can select here how many streams you want. So I want 3 streams. Then switch directions. Different type of this different type of the sequences. As you see here, a point is here, then output point will be otherwise same way. So like this also you can get the RTT round trip time. So here you can see the RTT trip time that from this port, this is source port and this is the destination port. Like this also you can get the round trip time. So now we are going to the eighth question. Now they ask for the what is the length of the each 6 TCP segments. So what I have got here is for every TCP segment, this is always 50 100 bytes. It is always less than 50 bytes. If you have any doubt, you can check here. If I am going to select this TCP segment, here you can see the bytes, 20 bytes, and here also you can see 1 byte. So every TCP segment contain the window size will be less than 50 bytes. If further it is not 50 bytes, less than 50 bytes, then first here is shown that download. First only I have said that download this zip file, then trace extract all the files, then you will get the TCP external trace one. So when you are going to upload this file, then you are going to get the TCP bytes as the less than 50 bytes only. If in case you are getting CCP segments as above 1500, then download this file and extract and upload this file. Then you will get the TCP bytes as the less than 1500 bytes only. So now we are going to question 9. So what is the minimum amount of the available buffer space advertised to the receiver for the entire phase? So here what I got is the amount received is 1710 dB and the window size is not permanent or not same for the same questions. Every time there will be changes. So here you can see calculated window size 517. Windows window is 517. So every time it will be not same. It will be changes according to the stream. So here you can see window 491, window size is 491. If you select this one, the window is 605 and calculated window size is 605. So it is not same. It is changing always. So that's why I have wrote here no, because the window size is more than the TCP size and it is changes for the every time. Then we are going for 10th question. Are there any retransmitter segments in the trace file? So if you want to answer this question, you have to check for the traces which are retransmitted again. So in this TCP segment, go to the protocol. So there are no, it is showing TCP segments. Here you can see retransmission, retransmitted. So what we are asking, what they have asked here is, are there any retransmitted segments in a trace file? I have got, these are not the trace files. These are only the packets which I have captured. That's it. Here you can see that they are out of the state. they are not captured. That's why and these are not considered. So that's why I have wrote here no, we can be the sequence number increasing continuously without repeat. So there is no retract network. So here what we have seen is retransmission segments are bit randomly with the sequence number. So sequence number is not increasing continuously, it is increasing. That's why we cannot say that the retransmit segments are present or not present. That's why I have wrote here no. Now we are going to question number 11. How much data does the receiver typically acknowledge in the AKK? Can you identify the cases of the receiver in ACK in every other segment? See on the 3.2 table 215 text. So here you can see the how many bytes of the data is going to transfer from the entering of the data to the exiting of the data. Here you can see the how many bytes. So let's check for the bytes. These are decision port. So say go to select protocol, select any protocol TCP segment. So here you can see that the length is 32 bytes. Here also you can see 1 byte. So there are no extra bytes are present here. These all bytes are less than 50 bytes only. So I have the header length also 20 bytes. If you are any doubt, you can check these files also. So what I have wrote here for the 11th question, it is 154 bytes and 250 bytes of the data. We don't have any identify that case. So I did not find any case here. Okay, the SNE receive segment. It is not typically receive the acknowledgment in the ACK. So now we can go to the question 12. Now that question 12 is very valuable one. We have to recheck for this one. It is the calculation one. So what they have asked is, what is the throughput? Means bytes transfer for the unit time for the TCP connection. In the connection of any TCP from the entering time to the exiting time, how many bytes of the data is getting transferred? Explain how you calculate this. So for this one, we will use a formula called 2 power n minus 2. We have a formula. So according to that formula, we will follow the this one. So first of all, I have first segment I have got is 1 byte, and the last segment I have got is 69 4091 bytes. So here what I calculate is from first byte the entry of the and first byte. Then the last byte is what are the TCP segments contain total number of the bytes. Then I have calculated the last byte bytes. So when you go to last one, which is the highest bytes or number of the bytes of the data. So HTTP, this is a port. So these three are HTTP ports contents are the which you have data we have selected now. Here you can see the data is incoming here, and it is outgoing here. So now they ask for this one only. Entry time of the data to the exit time of the data. Now we are going to calculate here according to this one. So what they have asked for? They have asked for the bytes. Here you can see TCP segment data 4181 bytes. So for the last of the TCP bytes, with the TCP resemble bytes are the 1531 bytes. The TCP byte which is the highest here. When I have calculated for the first time, I have got the 16491 bytes. So I have made a subtraction. So I have got this number of bytes. Then the transmission for the first byte is 0.2 seconds. How I calculate this means for the first one, here you can see this is the incoming one. So the first time is this one. For the last one, transmission for the last segment is 5.45. Means this last one. Like this, we also get the last one. Then I have calculated the subtraction between these two. So 5.1. Then I have made how I got the throughput. Throughput means we are getting a threshold value. We are selecting here now throughput. Means we are selecting the certain value. According to that value, we are going to capture the packets. And we are going to say that this is the highest value or this is the highest throughput. Or this packet and the highest value or highest uh, threshold value like that. So what I have done is 6049 bytes by that time. So I have got this one million megabytes per second. So will question after transfer the computer. So I have done nothing. They have asked for how you calculate this value. I have selected the bytes value of the highest value to lowest value. Then I have collected the time value of the highest value to lowest value. Then I have calculated the highest number of bytes by the highest number of the time they are taken. Then I have got the throughput. Now we are going to select the TCP congestion control in action. It is very simple. First one I have told you that what they are saying here that go to TCP graph utilities and sequence graph Stevens mark the word Stevens to plot your data. Select a TCP segments. What they are saying is first you have select the TCP segment in the captured packets. Then select the statistics TCP stream graph, then TCP sequence graph by Stevens. If you are getting any error in this one, please download this zip file, then extract all the files and import the TCP material trace one. Then you will get the all the true values. So we are going to the 13th question. What they are said, use the TCP sequence plus plotting tool for that segment. So please check this one. You can select any of the protocol TCP protocol contained here. So I am going to select one of the TCP protocol here. So here you can see the protocol TCP. Then what they have said, go to the statistics, then go to the TCP stream graph. I have set first only mark the word that is Stevens. What they have said, time sequence Stevens. Here you can see the time sequence. If you the thing packet which I have selected is TCP packet, here you can see the sequence number and the Stevens. So I am using Ethernet 2. This is the destination port number and this is the serial port number. It is changes from the 76820 Here you can see from 0. It is starting point and it is the ending point. If you want to change for this stream, change these streams, then you can select the stream, then switch directions. Here you can see the 0. Here is the ending point. Otherwise, you can select the same path. Here you can see this is the starting point from 0. So this is the ending point. Here, like this, you can select the TCP stream graph and also RTP time graph. 13th one, completed. So 14. Answer all each of the two above trace that you have gathered when you transferring the file. It is nothing. Any two questions you can calculate by this one. So here I have selected the TCP stream round trip time, or other you can take anything. I have taken RTT. So what they have asked is any two questions using that stream. So I have taken the RTT for this one. So I have got the graph as like this. So what is yeah, in this TCP segment what we have gathered is what are the important features of the TCP, how we are going to capture the packets of the TCP and capturing the bulk TCP transfer, how we are going to capture the TCP packets. So in this one TCP transfer, we have also seen what is the network capture and capturing the bulk TCP transfer, how we are going to see in the lab. So how we are going to analyze the capture traces by filtering, by integrating the graphs and extracting data. Here you can see the second point, interpreting the graph. Here we have seen that RTT graph, Stevens graph, and time sequence graph. Like this three, by using these three features, we are going to analyze the packets of the TCP. So these are the basics of the TCP. That is three-way handshake. Three-way handshake. Here also we have seen that SYN, SYN-ACK, and ACK. These three are called the three-way handshakes. Sequence and acknowledgement number sliding window. We have also covered these all the things. TCP congestion control. If any error is present in the data or transferring, we are going to control by using the TCP, either TCP correction and the TCP error detection. By conclusion takeaways, what we are going to see in this lab, what we have seen is the importance of TCP, how TCP is going to capture the packets in the Wireshark, and how the TCP is going to work in our daily life. We have all seen here. Thank you for seeing this.